Hi, welcome back. Today we're going to look at some review of applications, and they're from 9.1 to 9.4. And we're going to be working out some sample problems, okay? So the first problem, actually 5 of them, so the first one that we're going to look at is find the value of x such that the triangle upholds rules of right triangles. I mean, it's very straightforward. I mean, like I could have just left it at find the value of x, right? Okay. What was one of the main points? To show you something different and to kind of teach you a little bit of the math language. So that means actually such that. Okay. So here's the original problem. Okay. This is our triangle. Uh-oh, what do we do? Well, we have an altitude, so we probably should find that. And the reason being is that we can see a few things here, okay? We can see that right here, there's an actual right triangle. And we can see right here, that there is another right triangle. So even before we begin, we already have an idea of what to do. So what are the conceptual steps? And remember, these are just basic ideas of steps, okay? One of the things that you really should do always, though, is redraw the original problem and begin to think how to solve it, okay? And that's what we actually just did in a preliminary session, just try to figure out what we would do to solve the problem. How do we begin? Where do we begin? And what is it really asking? So one of the things that we do realize here is that we have a right angle, therefore we have two right triangles, and we can apply the Pythagorean theorem, because Pythagorean theorem works for right triangles, right? So we have to make a statement because we don't know what the altitude is. And I kind of made it a little wordy here, maybe too much, but let's just see. Let A be the altitude of the whole triangle in question. Okay? How I would have simplified it is let A be the altitude. Okay? So we have a variable and we define what it is within our problem. Okay? And that's essential because that's our unknown, right? That's what we're trying to figure out. So it's like a game, a puzzle. So I redrew just that one little triangle. And notice that we have two sides of it and we're missing one. So we're missing a leg in this case. So what I said here was identify the legs A and B. We want to also identify the hypotenuse. So that's what we did. Leg, leg, hypotenuse. Okay? And I just simply rewrote the Pythagorean theorem, substitute all of my correct assumptions in, or my parameters, or my values, or variables. Let's just say the stuff we're going to substitute, okay, for right now. And then I carried out the squares. A little bit, if you don't see how I got 16 times 5, I got that by taking 4 and squaring it. 4 squared is 16. And the square root of 5 squared is the square root of 5 times the square root of 5, which is the square root of 25, which is 5. Or the square root of 5 all squared is 5. So, and 8 squared is 64. So, carried out those operations. Then I subtracted 64 from both sides, realized that a squared is 16, and remember, when we're solving for the unknown, we're always looking for inverses or opposites. That's our primary goal at this point, okay? And remember that how to undo a square is by using the square root, and how to undo a square root is to actually square. Okay, so we now know that A is 4. Well, that's great. That's the altitude. Okay, so we now have the altitude. Perfect. Now, where did this other triangle come from? Well, it came from here, right? This was one of the right triangles that we were originally talking about. And now we know that the altitude is 4. Now, if we look at this triangle in question, the hypotenuse is x, and one leg is 24, and the other leg is 4. So we can still apply the Pythagorean theorem. So instead of writing all of these different steps out, like, what did I do here and what did you do there? Like, if you were going to show your work, I kind of am doing an overkill here of everything to kind of make sure that I explain it well enough. But the idea here is that you understand that there are two sides of a right triangle, and you can find the third by using the Pythagorean theorem. So I'm just repeating the same steps, and I'm going to solve for the new x in this case. And that's not a big problem, right? We just did it. So leg 4, leg 24, and hypotenuse x. So I did the substitution, carried out the squares, did the combination. So 16 and 576, 592. And then remember what actually undoes a square. It's the square root. So I just took the square root of both sides. Then remember, I'm looking for perfect squares. I'm literally looking for what 592 is divisible by easily. So you could always do 1 squared, but that's not really going to help you. So, 4, 9, 16, 25. Get the idea? The picture? And then once you do, I realize that 16 evenly goes in to 592 37 times. So I now can take the square root of 16 and the square root of 37. Well, the square root of 16 is easy. That's 4. But the square root of 37, a little harder, right? And it's prime, so we can't really do anything more with it to simplify. So our solution actually is 4 root 37. Okay? And that's the idea that we're looking at here. Okay? Look for the perfect squares. Okay? All right. Example 2. Boom. A spotlight is mounted on the eaves of a house 35 feet above the ground. A flower bed runs between the house and the sidewalk, so the closest the ladder can be placed to the house is 12 feet. How long a ladder is needed so that an electrician can reach the place where the light is mounted? Dun dun dun. Okay, so what do? Well, when in doubt, draw it out. So, like I said, always draw the problem out. Never try to do these problems in your head. You can get lost pretty quickly. Okay? So, I redrew it, and I made a picture. Okay? I made a nice right triangle. And I clearly labeled the ladder, and I colored it brown, because maybe it's a wood ladder, okay? And the ground is green because, hey, maybe there's a lot of grass on the ground, and the house maybe is just the siding on it is black or something. I don't know. But I tried to color coordinate it so that it can be made a little easier to see, okay? So then all I'm going to do is substitute the values given. But we need to make some variables, right? So we have to define some variables. So we're going to let h be the height of the spotlight. So that's from the ground to the eaves, right? Okay. Then we're going to let L be the length of the ladder. Okay, so that's actually what we're going to be solving for, right? Let G be the distance that the ladder is away from the house. So how far away is it from the house? Well, we know it's 12 feet, right? And this goes back to how to solve a type of word problem. You really want to learn to pick out what matters the most. There's a lot of information, but the English language is designed to give a lot of information at one point. The mathematics language also is designed to do that, but in a very interesting or maybe slightly different way. 35 feet above the ground. When I'm reading this, my eyes scan for certain things. Numbers are going to be one of them. Now, I know in the topics I'm dealing with a right triangle. So I already know one leg, if you will, or an altitude, if you will, some side of a triangle, if you will. Now, the other piece of information that I definitely know, right, is the closest it can be to the house is 12 feet. So when I read that whole problem out, the things that I looked for and the things that I was reading actually to myself was 35 feet above the ground, and the closest it can be is 12 feet from the house. Everything else is kind of informative, but not specific to the language of math. And that's what we're trying to get at. Remember, it's not repetition of a similar type of problem that tells you that you're good at math. It is conceptual understanding and the synthesis of the comprehension skills that are needed within the learning of the mathematics language. So it's a spiral. It builds on itself over and over and over again, and maybe crosses and does some really weird things later. Okay? But how to look at a word problem? This is the way we want to start. Okay? You want to read it, and what you want to do is pick out the essential pieces, okay? The pieces of information that are going to help you solve the problem the most. Scan for numbers. Scan for words like top, bottom, above, below, horizontal, things like this that will stand out within the problem. And then define your variables. And that's the real essence. So now that we have our defined variables, I labeled my new triangle with all of the new information. What we then did was we solved, right? I input L because that was the hypotenuse into C, right? 35 and 12 we put into legs, so carried out the squares, did the combination, and found out that 1,369 is a nice perfect square. It is 37 times 37. And the square root of 37 times 37 is just 37. So we now know the length of the ladder. See? This is important. This is important. This is important. This and this are also very important. So the problem can be simplified very easily and not have done all of the work I am showing out, is what I'm trying to get to you. It may look staggering at times, but when push comes to shove, mathematics is the language of science. It is the language of everything in a lot of ways. So to make an understanding of it, we have to have a good set of tools in our toolkit. Okay? So example 3. A railroad is inclined at an angle of 3 degrees. After driving 4,718 feet along this road, find the driver's increase in altitude. Round to the nearest foot. Okay? So, I've already drawn out the picture, right? And you might notice something kind of interesting about how I drew it. Now, because we have an incline, right? That means something's like raising up, like a drawbridge, so to speak. So you might see my little arrow here, right? Well, that's just something that we're going to talk about much later, probably maybe not even in this course, but maybe we'll get to it if we can. But notice how it's very similar to an angle, right? How we normally denote an angle would be something like this, right? Or maybe like that, right? But I'm using an arrow here. And the reason I am is because I'm trying to show you that it's an increase from the horizontal. It's something that's being raised a certain degree at a fixed point above the horizontal. Okay? So, obviously, we've already picked out the most important parts when we drew our triangle out. Now, how did I draw it out? Well, like I said, I knew certain things to look at. There's an angle of 3 degrees, it's inclined. There's a 4,000-foot road. Okay? What's the increase in altitude? Well, here's how we did it. Hypotenuse is 4,718. Leg is A. And I called this the angle of elevation, and I called it 3 degrees. So I'm kind of trying to relate the angle of elevation back to a simple base problem. So because we have an angle on one side, that means that we really should use our trig and our Sohcahtoa. So which one of these would it be? Well, clearly, I'm hoping you see that it's the sine. Why? Because it's the opposite over the hypotenuse, which is what the sign tells us in Sohcahtoa, right? That's the ratio. So, I just did my substitution and solved for A. So, how did I solve for A? I just multiplied because it tells me what to do. It says divide A by 4,718. The opposite, the inverse of division is multiplication. So I multiplied both sides by 4,718. Multiplying 4,718 times the sine of 3 degrees in degree mode gives us a rough approximation of 246.921, and that's nice for feet, but it said to round to the nearest foot. Now, just as a reminder of how to round, we always look to the number to the right of what we want to round. In this case, we want to round 6. So we look all the way to the next number, which is 9. Right? If that number, which happens to be 9, is bigger than 5, you would round the 6 up 1. If it was below 5, you do nothing to it and leave it as 246. So in this case, we rounded it to approximately 247 feet. Now, making sense of all of the problem, you did all that stuff and you just report an answer. That's wonderful. But what does it really mean when you report something? Well, it means you got to translate it back into the English language. So, the driver's increase in altitude is approximately 247 feet from the initial start. Something simple and basic, just to state the outcome of the problem, right? Because when presented a problem, no one's ever going to just give you some kind of figure and say, figure this out. They're going to give you a problem that's written in a way that you need to really address what's being asked and give a result, give a product, give a solution. Okay? Number 4. After heavy winds damage a house, workers place a 13-meter brace against the side at 45-degree angle. Then, at the same spot on the ground, they place a second, longer brace to make a 30-degree angle with the side of the house. And we're going to answer 2 little questions. Okay. So, clearly, I've drawn it out for you. Okay? Now, this is not a bad problem again, right? So, we know that there's a brace. The brace is against a house. So, it's 13 meters. Okay. Brace, 13 meters, and it's at a 45-degree angle with the house. Done. There it is. Right? We hope the house is plumb, meaning that it's level with the ground, right? If you drop something down, it's going to be like lying flat, if you've ever seen a plumb line. So, well, that's easy. That's really nice. That's a special right triangle, one of the ones that we have spent some time on. That's a 45, 45, 90. Now, again, remember, we're just theorizing or thinking or hypothesizing how we can actually figure out the problem. Now, we said read the problem and draw it out. Okay? Realize that we have 30 degrees and 45 degrees, so we're going to be looking at two special right triangles. Okay? Let me leave this highlighted for a second. So, what was the other piece of information when reading through this? Well, there's another brace at 30 degrees. Okay? And that's exactly what I did. Longer brace against the house and makes a 30-degree angle with the house. So, when reading these problems, make sure that you pick out some of the information, or if you can, all of the information, by just scanning and reading and thinking, what is the problem asking me to do? There are certain things that we learned, and we can put them all together so that we can solve a much bigger problem. And that's the point. We're going to keep spiraling, okay? So what I did here was I reminded you about the two special right triangles. In the 45, 45, 90, the two legs are S, and the hypotenuse is S root 2. And the 30, 60, 90, the side that's opposite the 30 degrees is S, the side that's opposite 60 degrees is S root 3, and the side that's opposite the right angle is 2S, or the hypotenuse. So, the first real question we have is, how long is the longer brace? You could kind of figure that one was coming. Well, you'll notice I made a little bit of adjustment here. I said, what's this distance D? Because it's not going to be changing, right? And what did we know about it? That they're both at the same point, same spot, right? So I happen to call that point the brace point, okay? Now, I've labeled D here as a distance. So I said, let D be the distance from the brace point to the house. Now, since we have the hypotenuse of a 45, 45, 90, it makes sense to start there, right? We know a value for a specific part of that triangle. So we relabeled it, redrew it, and everything, and then realized that 13 is the hypotenuse of a 45, 45, 90. So the hypotenuse is given by that expression, S root 2. So 13 is S root 2, or 13 is equal to S root 2, or the square root of 2. Okay? So when we solve it, we just divided both sides by the root 2, and this gives us an answer that we don't like, because no one wants to work forever and ever and ever. In this case, 13 would be working forever and ever because it'd be dividing by the square root of 2 forever. It's irrational. So we have to remember to rationalize. And what does that mean? That just means multiply numerator and denominator by what the denominator is. In this case, the square root of 2. At this level, it's the easiest way to think about it. If you have a square root of 4 in the denominator, multiply both numerator and denominator by the square root of 4. When you do so, you can see what you're going to end up with. What's the square root of 2 times the square root of 2? Well, it's simply 2, because the square root of 4 is 2. So now the 13 can be divided by 2 very easily, okay? And that's basically the essence of what we're talking about, rationalize. You'll find out more in another course very soon. D is now what we have found, and we found out that it is 3 square root of 2 over 2 meters, okay? Now, we have our other triangle, right? We have our 30, 60, 90 right here, right? So I drew that one out, as you can see here. I labeled the side that we had, D. But D happens to be what in the 30, 60, 90? Well, it's always opposite the 30 degrees, so S is actually D. And that's what I put here. Now, how do we find S, right? Well, we have it. It's 13 root 2 over 2. So how do we find that distance that we need to find for the brace, which is represented by the expression 2S? Well, we know that S is equal to 13 root 2 over 2 because, as we said, S equals D. And that's really important to realize. So if that's what we got and we have and we can work with, then we take 2S, which is the length of the longer brace, which is just taking S and multiplying it by 2. So I just took S and multiplied it by 2. Now, when you multiply and divide by 2, you have a factor of 1, right? 2 divided by 2 is 1. So our result is 13 square root of 2 meters. Now, the question asked for it in the tenths, so I reported it as 18.4 meters is the length of the longer brace. All right. So, looks very daunting. Looks really daunting most of the time. Okay? And that's fine. But we can overcome all of this as long as we read the problem, take our time with it, and really pick out the most important parts of it. Okay? So B says, how much higher does the longer brace reach than the shorter? Well, oh boy, this one might get us a little bit of trouble. As you can see, I rewrote the triangle, and I input some of the information that we already have, right? That we've already achieved. Now, what's the problem really asking? It's asking for this distance right here, right? The distance between the two braces. So how do we do that? Well, we take the bigger brace, right, the height of it, and we subtract the smaller base, right? In this case, those are heights. So if I take the smaller height away from the bigger height, I'm going to end up with the height. Okay. So, what do we know? Well, one of the things we already definitely know, because this triangle is a 45, 45, 90, right? Right? That this side here is exactly the same distance as that here. So that distance is that distance. Oh, and look, we labeled it as D. See? So I rewrote it in a very basic algebraic relationship, if you will, or equation. I subtract, or I take the difference in the heights to get the height I want. In other words, if I was going to use a better way of saying this, I would say delta H equals H desired. Okay? Now, what does that mean? That means the change in H, that means the difference of the H's, will give me what I want. And that's not as essential. This right here is not as essential to understand as this right now. However, if you do understand this, this is amazing to write down, okay? Because it does indicate that you're using the language and starting to develop your own characteristics within the language, which is great. Now, what you can see is I tried to do a color coordinating here. So the H, the height of the big that we're going to find, right, I did all in red. and the height of the small, which was actually the easier one, right? Because it's a 45-45, and we already know one of the sides. I did that all in purple. So let's do the small one first, actually, because it is the easier one. If this distance here is 13 root 2 over 2, then so is that distance. I just put it in. I just substituted, right? So that one's the easy one. Now let's look at the height for the big. Well, that one entails dealing with a 30, 60, 90. So the legs are a little different. So it takes a little more work, right? But not a big deal. We know the side that's opposite the 30-degree angle. And that's important. Why? Well, let's review for a second. The side that's opposite the 30-degree angle is always S. The side that's always opposite the 60-degree angle is given by the expression S square root of 3. Now, when we have that, we can work all our stuff around this, right? Well, now, we're not looking for the hypotenuse. We're looking for the what? A leg. And that leg happens to be d root 3, right? Let's go back up and remind you. D root 3. Oops, I missed it. There it is. Okay? Instead of it being D, it's S, right? So remember the right placement for these expressions. And the way that I've always remembered it, and I think it's always a nice way to help you, is to always look this way. Label the hypotenuse. Okay, it's always going to be 2S. That's fine. You can start there. My favorite place to start is right here at 30 degrees. 30 degrees is very special. Okay? I look at this degree. I look directly opposite, and then I label it S immediately. The next one, as I look at the 60, I look right across from that, and I always label it S root 3. And that's the one we're looking at right now, right? So, make sure that we label everything correctly. We've got our correct solutions. We now can address the correct height in question, which happens to be this right here. So, with all that being said, yeah, I know, a little bit of a load of stuff right there, right? Tons of stuff. I'm hoping you can see the kind of the sort of like mixture of geometry and algebra that I'm using right here to express the solution set. Okay? Now, what do I mean by that? You can see it clearly right here. This height minus this height will give me this height here. Okay? And that's what we're all about. So, very quickly, if it's just d times root 3, well, it's just this times root 3. Well, that's easy. And then the square root of 3 times the square root of 2 is the square root of 6. And the square root of 6 is not going to be reduced at all, right? So, at that point, right, I know I took you through a lot right there. Okay? I know I took you through a lot. Take it all in. It's a lot. But it's not too much. Okay? I gotta remind you about certain things and teach you some new things along the way. Okay? It's called spiral learning. So, all I did was literally put that into the calculator, achieved my goal, and found out that the change is actually 6.7 meters, or that height difference is 6.7. So then, remember, you want to clarify this with some kind of statement. The longer brace is 6.7 meters longer than the shorter brace. Very simple, very basic, don't have to go into a lot of words, okay? And that's the essence. Now, you can do this problem a lot quicker, like I said, but I'm trying to explain it so that every aspect is as explicit as possible, okay? The ideas that you want to keep in mind are, when you see these two beasts, the 30 and the 45, within two different triangles, you want to remember this and this. Why? Because those will tell you the expressions of what to set the values in question equal to. Okay? Like I said down here. Okay? So all of this comes together, and we're starting to hopefully gather the picture of how and why we solve these problems and why we're learning math. It's about solving and working out problems based on a set of tools that we have, and not so much on a memorization. Okay, we don't want to memorize how to solve a problem. That will get us into a lot of problems. Okay, no sort of pun intended. So let's go. Example 5. A train track through a mountain is 2,200 feet and makes an angle of 1.3 degrees with the horizontal. What is the change in elevation from one end of the tunnel to the other? Well, let's draw it out, right? Pick out the most important pieces. We've already seen how to do that, right? What's the most important piece right now? We know that there's a train track that's this long, right? And we know that it's at an angle of 1.3 degrees with the horizontal. Okay, so see how I processed the problem and drew it out. I started with a horizontal. And in fact, do you remember what this geometric piece is called? Remember way back when? Yeah, that's right. It's a ray. That's a ray. It starts at a point. And goes all the way to the right. Forever and ever and ever. That's a ray, right? So I started with that horizontal ray. And then I knew that I had to rotate that ray, right? Because that's what it said, from the horizontal, 1.3 degrees. So I did that. And then I labeled the tunnel, the 2,200 feet. And the last one, which may get some people right now, is this. Well, delta E in this case means difference in the elevations. And that's what I'm trying to indicate here. Okay? Delta E means delta E, a change in elevation. Delta means difference. Difference, delta. They both start with D. So I'm hoping that'll help remind you a little bit of some of these basic notations that we use, and you will see in upper level courses. Just trying to get you prepared for it. So, again, we know that we have to use our trig. Why? Because we have a right triangle, we have only one side that we're given for a value, and we have an angle. So we must use our trig, our base trig. So we remind ourselves of Sohcahtoa, right? If you stub your toe, you must soak your toe up. If you get into a problem, you must soak your toe up. So in this case, I realized, and hopefully you realized too, that we have to use the sign. Why? Because it's the opposite over the hypotenuse. And that's all I did. I substituted the values in, or in the variable. So the sine of 1.3 degrees is equal to delta E divided by 2,200. And again, the opposite of dividing by 2,200 is multiplying by 2,200. So that's where I got this. So after I typed that into the calculator, making sure I'm in degree mode, we came up with a change in elevation approximately 49.9. Okay, well, that's great. 49.9 is delta E. Well, 49.9 what? Right? doesn't have any units. It really matters to have these things. So the change in elevation for the tunnel is approximately 49.9 feet. A statement like that again, okay, that sums up what we were asked to find. Okay? Now, number 5 was a little bit easier, right? It might have been a little more difficult because we have to draw the problem out. And I still drew it out for you, but just remember that a lot of the problems you're going to see are not given with problems. Like, they're not drawn out for you. I think the toughest problem here is this B, okay? This, I think, will give you some time to think about, okay? There's a lot of stuff happening, and I wrote it up in a way that doesn't involve steps. And I'm hoping you realize that. It's not to make it more difficult. It's to show you a different way to write out the math. We're trying really hard to get you to read the math and not so much copy the math, okay? So you can see, as a review, a very summary review, we went from a very base example that was given a base problem, a very simple triangle. Worked it out through Pythagorean's theorem twice. We then came to a secondary problem, in which case we had to utilize the Pythagorean theorem in a way to solve for a specific length. Then we had to do a problem in which involved our basic trig, with angles of elevation trying to be incorporated into that. And then we had a problem that was probably the most difficult, right, to really think about at first, or maybe at last. I don't know. It all depends on how you think. But what made it really easy was knowing these. Okay? Those are essential. A wasn't that big of a problem, right? We just had to remember to rationalize the denominator, right? That was one of our biggest problems there. In the 30, 60, 90, we had to remember the ratios again and to set the correct expression in its correct place. So 2s, when we know that s is 13 square root of 2 over 2. Okay? Make your small solution. And then this problem is a difficult one, but hopefully you kind of see the process of the way that you might want to think about it in a more graphical term. Instead of just English and algebraic, maybe this is a more graphical way, and some people might find this a little bit easier. You'll have to let me know. But notice that it has no steps directly linked. But what were the key factors that you knew and know how to work the special right triangles, the 45, 45, 90, and the 30, 60, 90. And the last one, very basic trig ratio problem. In fact, probably one of the easier ones out of the whole problem, of the problem set, but because there's no drawing whatsoever associated with it, you got to really think about the problem. And this is the type of problem you're going to see in real life more often than not. And with that being said, I've gone way over time, and I hope this was helpful. Please let me know. Thank you. Have a great day.